Greetings, ladies and gentlemen. We are the Brainly Badges presenting a research topic about sulphate removal in industrial effluents using electrocoagulation sludge as an adsorbent. I'll ask my colleague to take you further and introduce our topic.
I'm Leo Berotti, and I'll be taking you through the introduction to our presentation. As we strive to preserve our ecosystem, recycling and reusing industrial and organic waste has become imperative. The alarming rate of waste disposal in landfills and incinerators poses significant environmental concerns, including water pollution and soil contamination. In particular, industrial effluents containing sulfates threaten our water resources and ecosystems. Effective sulfate removal is crucial to mitigate these impacts. Drawing from the success of recycling initiatives such as transforming corrugated iron sheets into valuable resources for wastewater purification, we can apply similar innovative approaches to sulfate removal. Today, we will explore the challenges, opportunities, and cutting-edge technologies for removing sulfates from industrial effluents, promoting a cleaner, more sustainable future for our environment and communities.
I'm Fiyosencha Makakula and I'll be taking you through the problem statement. The wastewater treatment plant in Buffalo City is facing a severe infrastructure damage and reduced operational lifespans due to untreated industrial effluents containing high concentrations of sulfate. This leads to the production of hydrogen sulfide with correct tanks and pipelines.
I'm Tabelo and I'm here to take you through the materials and methods. What you see on your left hand are some of the materials and reagents that are going to be used throughout the experiment, such as sodium sulfate, hydrochloric acid, sodium hydroxide, and others. And on your right hand is a diagram showing the preparation of the sludge from corrugated iron using electrocoagulation system. Moving forward, we have the methodology. The first method to be implemented is the batch adsorption experiment. This experiment will be performed in a 600 ml conical flask filled with 500 ml of water containing sulfate ions concentrations at pH ranging from 2 units to 10 units for 120 minutes. The removal percentage of contamination was calculated using the equation below, which is C0 minus C1 all divided by C0 multiplied by 100%, where C1 and C0 are the initial and final concentrations in the solution. The second method to be used is the adsorption isotherms and kinetic studies. In order to characterize the link between the quantity of sulfate ions adsorbed and its equilibrium concentration, both the methods were used in this investigation. But for this method, the equation used for this is called the Langmuir equation. The kinetic research was also included to remove sulfate ions from wastewater. The pseudo first and second order models were proposed and both the equations are shown below. So this is the first order pseudo equation where K1 is the rate constant, QE is the amount of sulfate ions adsorbed, and QT is the adsorbed sulfate ions amount on the EC sludge. Still on the pseudo order models, this is the second order equation where K2 is the pseudo second order rate constant, QE is the amount of sulfate ions adsorbed at equilibrium. Furthermore, values of K2 and QE were calculated from the intercept of the slope of the linear graph of T divided by QT against T.
Discussion and results. When analyzing the sludge produced from the EC process using FTIR spectroscopy, the presence of iron oxide magnetizes, indicating the magnetic properties of the sludge, which can be used for catalytic activities and separation methods. Hence, the transmittance percentages are very high on the figure shown in figure 2. FTI, FTIR revealed specific peaks such as 1,637 per centimeter corresponding to the carbonyl stretching, suggesting the presence of organic functional group within the sludge. Groups play a role in the absorption isotherms. Absorption of sulfate onto the EC sludge is mostly influenced by following optimized parameters. The experimental data was fitted in the Langmuir isotherm and Frank-Lick isotherm, and it fitted mostly in the Langmuir isotherm, confirming the formation of sulfate monolayer on the EC sludge as an adsorbent. The figures A and B show that the Langmuir isotherm fitted mostly for the experimental data.
I, Zulu, will be concluding on what my colleagues mentioned above. In this study, the sludge produced from electrocoagulation process was successfully used to remove more than 95% of sulfates from industrial waste and synthetic samples, even at low pH levels. This was achieved through iron and aluminum hydroxide complexes, which helped absorb the sulfates. The results show that the Langmuir equation was a better fit than the Frank-Lick isotherm, indicating an even distribution of active sites on the sludge. A pseudo-second-order kinetic model best explains how sulfates were removed, confirming that it happened through chemisorption. The sludge can be reused up to 3 times, still removing 60% of the sulfates. This research can help develop methods for removing high-level sulfates to protect wastewater treatment plants from contamination and change.